Hi everyone, welcome back to my channel. I'm Jari Linggayo, and today we're going to enter a magical world not of spirits and dragons, but of math. Just like in Spirited Away, where Chihiro learns to balance between two worlds, in math, we also deal with balance. Today, we'll find balance in rational inequalities. But wait, what are rational inequalities? They're just inequalities that have fractions with variables in them. Our goal is to find which values of x make this fraction true. When is it positive? When is it negative? And where is it not even allowed? In this lesson, we'll go step by step, find the critical points, and test each interval, and finally, graph the solution using parentheses and brackets. So if math sometimes feel like mysterious spirit world, don't worry. By the end of this video, you'll move through it with confidence, just like Jiro crossing the bridge.
Let's jump straight into example 1. X plus 2 over x minus 3 is greater than 0. First, find where the numerator equals 0 and where the denominator equals 0. These are the critical points where the signs can change. In here, positive 2 becomes negative 2. Now, for x negative 3, equal this again into 0. And the negative 3 becomes positive 3. Take note that any x that makes the denominator 0 cannot be in our solution. That means we exclude it. After finding the critical points, we now graph it. First, plot the positive 3 and the negative 2. Now, we write it like this. Negative infinite to negative 2. And we enclose it with parentheses. Next, the middle interval. We're gonna write it like this too, negative 2 and 3. For the last interval, open parentheses, 3 and a positive infinite and close it. Now, we will test exactly one number from each interval to determine the sign of the fraction there. Pick any easy value inside each interval. In here, I'll choose negative 3. Now, you're gonna substitute it using the equation. Just change every x into negative 3 and just solve it. Negative over negative divided, that makes it positive. So, 1 over 6 is greater than 0, that makes it positive or true. For the middle interval, I choose 0. And just repeat the process, substitute it, and solve it to determine the sign. Here, the sign is negative, so negative 2 over 3 is not greater than 0, so it's false. For the last interval, I choose positive 4. Now, we want where the expression is greater than 0, so we pick the positive intervals or the true intervals. Those are negative infinite to negative 2 and 3 to infinite. The final answer is negative infinite negative 2 in union with 3 positive infinite. Now, for example number 2, we're gonna use 2x minus 5 over x plus 1 is less than and equal to positive 3. We want 0 on one side, so put the 3 into the other side and subtract them. Now, this gives us negative x negative 8 over x plus 1 is less than 0. It's helpful to remove that leading negative in the numerator, so we multiply each sides by negative 1. Now, that gives us x plus 8 over x plus 1. Take note that multiplying an inequality by a negative flips the inequality sign. Now, we can start getting the critical points. Now, let's plot it. The sign greater than or equal to means we're looking for all x values where the expression is greater than 0 or equal to 0. So, If the fraction actually equals 0 at some point, we include that value. That's when we use a bracket. Now, is x equals negative 8 allowed? We check the denominator, negative x plus 1. If x is equals to negative 8, then x plus 1 is equals to negative 7, which is not 0, so it's safe. That means the expression actually equals 0 at x equals negative 8, and the inequality sign greater than or equal to says we should include it. In the first interval, I choose negative 9. And take note, you are going to substitute it in the simplest form or the simplified form of the equation. In the middle interval, I chose negative 5. Here, the answer is negative 4, which means it's false, since negative 3 over 4 is not greater than 0. In the last interval, I chose x equals 0. Take note that when a value is included, we use a bracket. When a value is not included, we use a parenthesis. Now, this is the final answer. For my last example, we're gonna use x squared minus 4 over x squared plus x minus 6 is greater than and equal to 0. First, let's start by factoring the numerator, which is x minus 2 and x plus 2. Then, we factor out the denominator. X minus 2 cancels algebraically, but x equals 2 makes the original denominator 0, so x equals 2 is excluded. Now, let's find the critical points. Don't forget to find the critical points of the x minus 2, even if it's cancelled. When plotting the points, don't forget to plot the x minus 2 even if it's cancelled. Here, the negative 2 is included, so we use brackets. Now, for the first interval, I chose negative 4. When substituting, you will use the equation where you cancelled the x minus 2. Now, the simplest form of the equation is x plus 2 over x plus 3. This is the equation where you will substitute the x equals negative 4. Negative 4 plus 2 over negative 4 plus 3. That's equals to negative 2 over negative 1. Negative over negative becomes positive. So the answer is positive or true. Now for the second interval, I choose negative 2.5. Now just substitute it. Negative 2.5 plus 2 over negative 2.5 plus 3. That makes it negative 0.5 over positive 0.5. Since the answer is negative 0.5 over 0.5, is not greater than 0, that means it's false. For the third interval, I'm gonna choose x equals 0. So 0 plus 2 over 0 plus 3. That makes it 2 over 3. And 2 over 3 is greater than 0, so it's true. Next, for the last interval, I'm gonna choose x equals 3. So 3 plus 2 over 3 plus 3, that makes the answer 5 over 6. 5 over 6 is greater than 0, so it's true. We want greater and equal to 0, so keep positive or true intervals. Now that's your final answer. And that's it, everyone. You did such an amazing job working through those rational inequalities with me today. If you found this helpful, give this video a thumbs up, share it with a friend who's also learning rational inequalities, and don't forget to subscribe for more step-by-step math tutorials. I'm Jari Linggayo, and this has been Rational Inequalities, the spirited way. Keep learning, keep growing, and I'll see you in the next video. Bye, everyone!